The Fermi Paradox. Where is everyone? Here's a fact. In our galaxy, the Milky Way, there are between 100 and 400 billion stars. 400 billion. That's more than grains of sand on every beach on Earth. And most of these stars have planets. Many of them in the habitable zone, where liquid water can exist, where life can exist. And that's just our galaxy. There are 2 trillion galaxies in the universe. 2 trillion. Now, simple math. If even 1 in a billion stars has a planet with life, that gives us hundreds of billions of civilizations in the observable universe alone. So the question, where is everyone? Why don't we see their ships? Why don't we hear their signals? Why don't we find their traces? Nothing. Silence. Absolute, deafening silence. This is the Fermi Paradox, named after Enrico Fermi, an Italian physicist who in 1950, over lunch with colleagues, suddenly asked, "So where is everybody?" And since then, nobody has given a convincing answer. Today we'll go through every major hypothesis, from the most optimistic to the most terrifying. And I'll be honest, some of them make you wonder whether we even want to find anyone. But first, context. Because without context, the paradox doesn't work. Our universe is 13.8 billion years old. Earth is 4.5 billion. Life on Earth, about 4 billion. But intelligent life, Homo sapiens, just 300,000 years. We've been sending radio signals for just over 100 years. Spacecraft, 60. We're infants. Cosmic infants. Just barely opened our eyes. Now imagine a civilization that's 1 million years older than us, or 100 million, or 1 billion. What can it do? What technology does it have? We can't even imagine. And here's what matters. The Milky Way is 12 billion years old. If any civilization appeared even 1 million years before us, it would have already colonized the entire galaxy. Even at a speed 1,000 times slower than light, it would take only 10 to 20 million years. By cosmic standards, an instant. But we see no traces of colonization, no megastructures, no Dyson spheres, no radio signals, nothing. Where is everyone? Let's start with the optimistic explanations, the ones that say, everything's fine, we just haven't found them yet. First explanation, distances. The universe is absurdly large. The nearest star, Proxima Centauri, is 4 light-years away. That means light takes 4 years to get there. And our fastest spacecraft, Voyager, would take 70,000 years. Even if there are thousands of civilizations in the galaxy, we might simply be too far apart. Like 2 ants on different continents, both alive, both searching, but finding each other, impossible. Second explanation, time. We've been listening to space for only 60 years. 60 years out of 13 billion. That's like turning on a radio for 1 second and being surprised you didn't catch a station. Maybe the signal was yesterday, or will be tomorrow, or is right now, but on a frequency we're not checking. Third explanation, we're looking for the wrong thing. We're looking for radio signals, electromagnetic waves. But what if an advanced civilization switched to something else long ago? Quantum communication, gravitational waves, neutrino beams, something we can't even imagine. We're like a jungle tribe looking for smoke signals, while a plane with Wi-Fi flies overhead. Fourth explanation, we already found it but don't understand. Maybe alien signals are in our data right now, in the noise of radio telescopes, in anomalies we dismiss as interference. We just don't know what to look for. Like a child staring at a book but unable to read. These are all optimistic versions. They say, life exists, intelligence exists, we just haven't met yet. A matter of time and technology. But there are other explanations, less pleasant ones. Fifth explanation, the rare Earth hypothesis. Maybe life isn't the norm. Maybe Earth is a cosmic miracle, a unique combination of circumstances that's almost impossible to replicate. Think about what we need. A star of the right type, not too hot, not too cold. A planet at the right distance. A magnetic field that protects from radiation. A moon that stabilizes the axial tilt. A Jupiter that vacuums up asteroids before they destroy us. Plate tectonics that recycles the atmosphere. Liquid water. And 4 billion years of stability without global catastrophes. Each of these factors alone, not rare. But altogether, maybe it's a combination that hits once in a trillion planets. But even if life emerged, that's not intelligence yet. And this is where it gets really interesting. Life on Earth has existed for 4 billion years. 4 billion years of evolution. And only in the last 300,000 years did intelligence appear. Technological intelligence, capable of sending a radio signal, has existed for 100 years. 100 years out of 4 billion. That's 0.0000025%. Dinosaurs existed for 165 million years and didn't invent the wheel. Not because they were stupid, but because evolution doesn't need it. Evolution doesn't aim for intelligence, it aims for survival. And for survival, intelligence is completely optional. Bacteria have been alive for 3.5 billion years without a single thought, and they're doing just fine. Maybe intelligence is an anomaly, an evolutionary glitch, a side effect that happened once on one planet and nowhere else. This is called the Great Filter. The idea is that on the path from dead chemistry to a spacefaring civilization, there are barriers, steps that are nearly impossible to overcome. And somewhere on this path, there's a filter, a wall, that only 1 in a billion gets through. The question is, where is this filter? Behind us or ahead? If behind, we got lucky. We already passed the hardest part. The origin of life, the jump from single cell to multicell, the emergence of intelligence, all of that was the filter, and we made it through. We're rare, but we're alive. If ahead, we're doomed. It means every civilization that reached our level eventually destroys itself. Nuclear war, climate catastrophe, artificial intelligence gone rogue, biological weapons, something we haven't even invented yet. And this is where it gets truly scary. Because if the Great Filter is ahead, it means every civilization in the universe reached a certain point of development and died. No exceptions. This explains the silence. Not because no one exists, but because everyone is dead. Harsh? Yes. But this is one of the most serious hypotheses in astrobiology, and it has indirect evidence. We ourselves, right now, are balancing on the edge of several potential catastrophes. Nuclear weapons, climate change, uncontrolled AI. We might, right now, be approaching our filter. And you know what's the worst part? If we find life on Mars, microbes, bacteria, anything, that's bad news. Very bad. Because it means the origin of life isn't the filter. Life appears easily, which means the filter is ahead. And we haven't reached it yet. The more life we find in space, the worse our odds. Paradox, right? The discovery everyone celebrates is actually a death sentence. But there are explanations even darker, and these truly terrify. The dark forest hypothesis. It was popularized by Chinese writer Liu Cixin in his trilogy The Three-Body Problem. But behind it is real logic, and it's cold as space. Imagine, The universe is a dark forest. Every civilization is a hunter creeping between the trees. Silence. You don't know who else is hiding in this forest. And here's the main rule. If you discover another hunter, you must kill them first. Because if you don't, they'll kill you. Why? Because you can't know the intentions of another civilization. You can't be sure it's friendly. And resources in the universe are limited. Any civilization that discovers you is a potential threat. In 1,000 years, in 1,000,000, doesn't matter. If it can destroy you, it will, just in case. In this model, silence isn't emptiness. Silence is fear. Everyone is quiet because those who spoke are already dead, destroyed by other hunters. Quickly, quietly, without negotiation. And here's what's terrifying. We're screaming. Since the 1920s, we've been sending radio signals into space. Our TV broadcasts, radio stations, radars, all of it goes into space at the speed of light. Right now, our signals have traveled 100 light years, reached hundreds of star systems. If the dark forest hypothesis is correct, we just gave away our location to every hunter within 100 light years. In 1974, we sent the Arecibo message, a directed radio signal toward the globular cluster M13. 25,000 stars. We literally shouted into the darkness, "We're here!" with coordinates, with our DNA structure, with a description of our solar system. Stephen Hawking said until the end of his life that this was madness. He compared it to how indigenous peoples of America met Columbus. Not the happiest contact in history. But maybe it's already too late. Maybe our signals have already been intercepted, and someone is already on their way. Or has already decided we're not worth the attention. Or has already pressed the button. We don't know. And that's the essence of the dark forest. You never know. Until it's too late. Okay, caught your breath? Let's move to the next hypothesis. It's not as dark, but no less strange. The zoo hypothesis. Proposed by astronomer John Ball in 1973, the idea is simple. They know about us. They watch us. But they don't interfere. Like how we observe animals in a nature reserve. Don't touch. Don't make contact. Just watch. Study. Maybe they have a rule. Don't interfere with the development of young civilizations, like the Prime Directive from Star Trek, only for real. Sounds like fiction? Maybe, but think about this. If a civilization has existed for 1,000,000 years, it's seen thousands of young civilizations. It knows what happens during contact, knows that young civilizations are fragile, that contact can break them. Like showing a 5-year-old quantum physics, they won't understand. They'll break. Maybe they're protecting us, waiting until we mature, until we reach a certain level on our own, and then they'll open the doors. There's a similar version, the planetarium hypothesis. We're not in reality at all, we're in a simulation, and those who created us don't show us other civilizations because they're not in the program. We're an experiment, one of millions of runs, and the observers just watch what happens. Sounds crazy? Yes, but Elon Musk believes the probability that we're living in base reality is 1 in a billion. Philosopher Nick Bostrom wrote an entire scientific paper proving we're almost certainly in a simulation. And if that's the case, the Fermi Paradox is solved simply. There is no paradox. There's a program, and we're alone in it. One more version. They're among us. No, I'm not talking about reptilian conspiracy theories. I mean a subtler idea. What if an advanced civilization is so different from us that we can't recognize it? What if it exists at a different scale, in a different dimension, in a different form of matter? We're looking for little green men, but maybe we're surrounded by intelligence that looks like dark matter, or quantum fields, or the very fabric of space-time. And it's looking at us, but we can't see it, because we don't know where to look. Okay, let's switch gears. Let's talk science. about actual attempts to find someone. The SETI program, Search for Extraterrestrial Intelligence, running since 1960. Over 60 years we've been pointing radio telescopes at stars and listening. And in 60 years, almost nothing. Almost, because there was one signal. August 15, 1977. Astronomer Jerry Eman was working on the Big Ear radio telescope in Ohio, and he caught a signal that lasted 72 seconds. Narrowband, powerful, at the hydrogen frequency, exactly the one where an intelligent civilization should theoretically broadcast. Eman circled the data on the printout with a red marker and wrote, "Wow." That's how the signal got its name, the WOW signal. It was never caught again. 60 times they pointed the telescope at the same spot in the sky. Silence. One time, and that's it. As if someone flashed a flashlight and turned it off. What was it? We don't know. Maybe interference, maybe a comet, or maybe someone actually transmitted something, once, in our direction, and left. There are other oddities too. Tabby's star, KIC 8462852. In 2015, astronomers noticed its brightness drops irregularly, sometimes by 22%. That's a huge number. A planet the size of Jupiter blocks a star by only 1%, and here, 22. First thought, megastructure, a Dyson sphere, a giant construction around the star that collects its energy, built by a civilization millions of years ahead of us. Later it turned out it's most likely a dust cloud or a swarm of comets. But for a couple of months, the entire world froze, because for a second it seemed we found it. In 2017, a telescope discovered Oumuamua, the first interstellar object to fly through our solar system. Strange shape, elongated like a cigar. Strange acceleration, as if something was pushing it. Harvard astronomer Avi Loeb directly stated, "This could be a probe, an alien probe, just flew by and left." Most scientists say, no, it's just a rock. Strange, but a rock. And Loeb says, we're dismissing the obvious because we're afraid. Afraid of being wrong. Afraid that someone actually flew by and didn't care about us. Who's right? I don't know. But the fact remains, Oumuamua is gone. We didn't get to properly study it, and there won't be a second chance.
Let's talk about the Drake equation. An attempt to calculate how many civilizations should exist in our galaxy right now. A formula invented by astronomer Frank Drake in 1961. It looks simple. Take the number of stars born in the galaxy each year, multiply by the fraction of stars with planets, multiply by the average number of planets in the habitable zone, multiply by the probability of life emerging, multiply by the probability of intelligence appearing, multiply by the probability of developing technology, multiply by the average lifespan of a civilization, and you get a number. The number of civilizations in the Milky Way right now. The problem is, we don't know any of these multipliers, except the first one. Stars are born, we can see that. Everything else, pure guesswork. Optimists plug in large numbers and get millions of civilizations. Pessimists plug in small ones and get one, us. But here's what's interesting. Even with the most modest estimates, even if the probability of life is negligible, the scale of the universe compensates for everything. 2 trillion galaxies, 300 sextillion stars. With numbers like that, even a probability of 1 in a trillion gives you thousands of civilizations. And we're back to the same question. Where is everyone? Maybe the problem isn't in the numbers. Maybe it's in the last multiplier, the lifespan of a civilization. What if technological civilizations don't last long? What if the average is 1,000 years, or 500, or 100? We've been a technological civilization for just over 100 years, and we've already nearly destroyed ourselves twice. The Cuban Missile Crisis of '62. One man, Vasily Arkhipov,
didn't press the button to launch a nuclear torpedo. One man. Between us and nuclear winter was one man. Maybe most civilizations don't survive. Maybe technology is poison, gives you the power of gods but the wisdom of an ape. And sooner or later, the ape presses the wrong button. Then the paradox is solved simply. Civilizations flare up like matches, burn brightly, and go out. 100 years, 200, 1,000. By cosmic standards, nothing. The chance that two matches are burning at the same time in a galaxy of 200 billion stars is almost zero. We're alone, not because life doesn't exist, but because it doesn't last. There's another hypothesis that's rarely discussed, but it might be the most realistic of all: the hibernation hypothesis. Imagine a civilization that's existed for 1 billion years. It's explored everything, built everything, solved every question. What does it do? Where does it expand? Why? Maybe after a certain level of development, civilizations go inward, not into space, but into themselves, into virtual worlds, into simulations, into digital paradise spaces where you can live 1 billion years of subjective time in 1 second of real time. Why spend energy colonizing a galaxy when you can create a perfect universe inside a computer? Why build a Dyson sphere when you can optimize your consciousness to a level that barely needs energy? This isn't fiction. We're moving in this direction ourselves. Virtual reality, artificial intelligence, neural interfaces. In 100 years, maybe, most humans will live in digital worlds. In 1,000, maybe all. If this is a universal path of development, then space is empty not because no one exists, but because everyone left. Inward, into their perfect universes. And they don't care about the real world, about us, about our signals. They're not silent, they're simply not listening. Because real space for them is like a country trail for someone who has the internet. Why walk a trail when you can be anywhere with one click? Another version of hibernation is literal. The universe right now is hot. Cosmic microwave background, 3 Kelvin. That's not much, but for computation, it's inefficient. Computation is more efficient the colder the environment, laws of thermodynamics. Some physicists suggest that advanced civilizations might hibernate, wait for the universe to cool down. In trillions of years, the background temperature will drop to near absolute zero. And then, for 1 unit of energy, you can perform billions of times more computations. They're sleeping, waiting, for their time to come. And we live in the early, hot, inefficient era, and think we're alone. But around us, sleeping giants, who will wake up in trillions of years, when we're long gone. Let's talk about what we can actually do. Not in 1,000 years, now, in the coming decades. The James Webb Space Telescope, launched in 2021, cost $10 billion. And it can do something no telescope could before. It can analyze the atmospheres of exoplanets. What does that mean? When a planet passes in front of its star, the star's light passes through the planet's atmosphere. And in that light, spectral lines, a signature of gases, oxygen, methane, water, carbon dioxide. If we detect oxygen and methane simultaneously, that's almost certainly life. Because methane and oxygen react with each other. Without life, they can't coexist. If both are present, something is producing them, something alive. We could find life within the next 10 to 20 years. Not intelligent, not technological, but life. Microbes, bacteria, single-celled organisms. That alone would be a revolution. But there's another approach, the Breakthrough Listen program, funded by Yuri Milner, a Russian billionaire. $100 million over 10 years, the most extensive search for extraterrestrial intelligence in history. They're listening to 1 million nearby stars, 100 nearby galaxies, on all frequencies, with sensitivity no one had before them. If anyone within 200 light-years sends a signal with the power of an ordinary radar, they'll hear it. So far, silence. But the program has only been running since 2016, too early for conclusions. There's also the Breakthrough Starshot project. The idea: send thousands of tiny probes to Proxima Centauri, each probe the size of a postage stamp, accelerated by laser to 20% the speed of light, arrives in 20 years and sends data back. 20 years of flight, plus 4 years for the signal to return. Total, in 24 years we could receive photographs from another star system, close up, from a distance where you can see continents on a planet. If someone's there, we'll see. This isn't fiction, it's an engineering project, with a concrete budget, with concrete timelines. And it could work within our lifetime. The question is, do we want to know the answer? Are we ready for what we'll see, or for seeing nothing at all? Let's come back to philosophy, because the Fermi Paradox isn't just about physics, it's about us, about how we think about ourselves. Here's an interesting thought. We're looking for life like us, carbon-based, protein-based, with DNA, with oxygen metabolism. But what if life can be completely different? What if we're looking for a mirror when we should be looking for something that doesn't resemble a reflection at all? On Earth, there are extremophiles, bacteria that live in boiling springs, in sulfuric acid, in nuclear reactors, in Antarctic ice. Life on Earth adapts to conditions we considered impossible for life. Every time scientists say, life can't exist here, life proves them wrong. So why do we think life in the universe must look like ours? Maybe there's silicon-based life, or life based on liquid methane, like on Titan, or based on energy fields, or based on something we can't detect with our instruments. Because our instruments are tuned to carbon, to water, to oxygen. We're looking for ourselves and not finding us. But maybe life is teeming all around us, and we simply don't recognize it. Astrophysicist Carl Sagan said, "Absence of evidence is not evidence of absence. We haven't found doesn't mean there's nothing. Maybe we're just blind." And one more thought, the Kardashev scale. Soviet astrophysicist Nikolai Kardashev in 1964 proposed a classification of civilizations by energy consumption level. Type 1 civilization uses all the energy of its planet. We haven't reached that yet. We're somewhere around 0.7. Type 2 civilization uses all the energy of its star, a Dyson sphere, a complete shell around the star collecting every photon. Type 3 civilization uses the energy of an entire galaxy, hundreds of billions of stars, under the control of one civilization. We're looking for traces of Type 2 and 3 civilizations, because they should be visible. A Dyson sphere blocks a star's light. That's detectable. A Type 3 civilization changes the luminosity of an entire galaxy. That's also detectable. But we see nothing. Not one dimmed star. Not one strange galaxy. Maybe civilizations don't develop along the Kardashev scale. Maybe they go a different way. Inward, not outward. There's one more hypothesis that personally won't let me go. The transcendence hypothesis. The idea is this: any sufficiently advanced civilization eventually stops being a civilization in our understanding. It transcends, goes beyond physical reality, becomes something we can't describe. It's like a caterpillar and a butterfly. A caterpillar crawls on a leaf. Its world is two-dimensional: leaf, branch, tree. And then it becomes a butterfly, and its world is three-dimensional: air, space, freedom. For other caterpillars, It disappeared, vanished, as if it never existed. But it's there, just in a different world. A world that caterpillars can't see. Maybe we're caterpillars, crawling on our leaf, three-dimensional space. And around us, butterflies, civilizations that went beyond, into other dimensions, into other forms of existence. And for them to come back to us is like a butterfly becoming a caterpillar again. Why would it? Sounds like mysticism. But here's a fact. We ourselves, in the last 100 years, have moved from the physical world to the informational one. Most of humanity lives in their smartphone, on the internet, in digital space. In 1,000 years, maybe we'll be fully digitized. In 1,000,000, maybe we'll become something that has nothing to do with matter at all. If this is a universal law, then the Fermi Paradox is solved. All civilizations transcend, leave, and leave empty space for the young ones, for those still crawling on their leaf. And you know what's the most beautiful thing about this? If it's true, then the silence of space isn't loneliness. It's a promise. A promise that one day, so will we. One day, we too will become butterflies and see what's impossible to see right now. Or not. Maybe we'll stay caterpillars forever. Maybe the filter is exactly in this transition, and those who can't transcend go extinct. We don't know. All right, let's wrap up, because there's a lot of information, and it's easy to get lost. The Fermi Paradox is the contradiction between the enormous number of potential civilizations and the complete absence of their traces. We've covered more than a dozen hypotheses. Let's run through them quickly. Optimistic. Distances are too great. We're looking for the wrong thing. We've been listening too short a time. Signals are already in our data, but we don't understand them. Neutral. Rare Earth. Intelligence is an anomaly. Life exists, but intelligence doesn't. Dark. The great filter. All civilizations destroy themselves. The dark forest. Everyone hides and kills anyone who sticks out. Strange. The zoo. We're being watched. Simulation. We're programmed. Hibernation. Everyone's waiting for better times. Transcendence. Everyone has left beyond. Concrete. We're searching with SETI, Webb, Breakthrough Listen. Found so far one wow signal, one strange star, and one strange rock. Which hypothesis is correct? Nobody knows. Maybe a combination of several. Maybe none of them. Maybe the answer is so simple we can't see it right in front of us. Or so complex that we'll need another 1,000 years to understand it. But here's what I personally think, and this isn't science. This is my opinion. I think the silence is normal, not because no one exists, but because space is unimaginably large and unimaginably old, and we are unimaginably young. 100 years of searching, out of 13 billion. That's like opening one grain of sand on every beach in the world and saying, there's no gold here, there's no gold anywhere. We've only just begun, and maybe the most important thing isn't the answer to the paradox, but that we ask the question, that we build telescopes, send probes, listen to space, shout into the darkness, even when the darkness doesn't answer. Because shouting into the darkness, that's what humanity is. That's our essence. Not finding answers, but searching for them. Not reaching the destination, but walking. Maybe we're alone, maybe not. But either way, we're searching. And that makes us unique. Not in the universe, because maybe someone else is searching too, but in our own history. For billions of years, matter just existed. And then, one small piece of that matter looked up and asked, "Is anyone out there?" That's a miracle, regardless of the answer.
The next video is about how the universe will die. Heat death, the big rip, the big crunch. 3 scenarios for the end of everything, and none of them are fun.